Close your eyes. Imagine the darkest room you have ever been in. Now, turn off the darkness. Remove the walls. Remove the air. Remove the empty space itself. What is left? According to the standard story of cosmology, this is where we began. Nothing. And then, 13.8 billion years ago, a miracle. We are told that the universe erupted from a single point of infinite density, the Big Bang. The moment the clock started ticking. The moment before became after. It is a clean, simple story. It feels like a beginning. But there is a problem that haunts the mathematics of modern physics. You see, nature hates infinity. When we rewind the tape of cosmic history, our equations work perfectly until they hit that very first instant. At t equals 0, the math breaks. The laws of physics dissolve. The story of the Big Bang stops making sense. This suggests something terrifying, yet profound. The Big Bang was not the beginning. It was a bridge. If the universe didn't start with the Big Bang, then what was here before? Was it a dead universe, a mirror world, or a timeless ocean of chaos? Tonight, we are going to journey past the edge of time. We are going to look for the ghosts that haunt our reality, traces of a cosmos that lived and died so that we could exist. Relax. Let the day fade away. And let's look into the dark. To understand the before, we must first understand why the beginning is a lie. For 100 years, general relativity has been our best map of the universe. Einstein taught us that space and time are like a fabric. If you put a heavy object on a mattress, it sinks. That is gravity. Now, imagine the entire universe, every star, every galaxy, every atom running in reverse. The fabric of space isn't just sinking, it is being crumpled into a fist. As we go back 13 billion years, the visible universe, a sphere 93 billion light-years across, is crushed down to the size of a grapefruit. Go back further, the size of an atom. Further, the size of a proton. At this point, Einstein's smooth fabric meets the jagged, chaotic world of quantum mechanics, and they do not get along. General relativity says space creates a smooth curve. Quantum mechanics says, at tiny scales, space is a frantic, jittery mess of fluctuations. When you try to force the entire cosmos into a point smaller than an atom, a singularity, the temperature becomes infinite. The density becomes infinite. In physics, infinity is not an answer. It is a sign that your theory has crashed. It means we are missing a piece of the puzzle. The universe cannot start from a singularity. Something must have prevented the collapse from reaching zero. Something must have pushed back. Enter the theory of loop quantum gravity. This theory proposes a radical idea. Space is not a smooth sheet. It is made of atoms of space. Tiny, indivisible loops of gravity woven together like chainmail. Because space is made of these tiny chunks, there is a limit to how small you can crush it. Imagine a sponge. You can squeeze it. You can crush it down to a fraction of its size. But eventually, the material of the sponge itself resists. You cannot squeeze it into nothing. If you squeeze hard enough, the sponge pushes back. This is exactly what might have happened 13.8 billion years ago. Imagine a previous universe, a universe much like ours, but old, dying. Over trillions of years, its expansion slowed down and reversed. Gravity began to pull everything together. A big crunch. Galaxies collided. Stars merged. The cosmos shrank, but it didn't shrink to a singularity. When it reached the Planck scale, the smallest possible size in nature, quantum gravity became repulsive. Gravity reversed its polarity. Instead of crushing into nothing, the universe bounced. The Big Bang was not a beginning. It was a recoil. The death of the old universe became the birth of the new one. If this is true, We are living in an eternal cosmic lung, expanding, contracting, bouncing, repeating. We have no idea how many times this has happened. We could be the first cycle, or we could be the trillionth. But if we are a sequel, surely the previous universe left a scar? A footprint? Sir Roger Penrose, a Nobel laureate and one of the deepest thinkers in human history, does not believe in the bounce. He asks a simple question about entropy. Entropy is the measure of disorder. Things naturally go from order to disorder. An egg breaks, it does not unbreak. A star burns fuel, it does not create it. This is the arrow of time. But if the universe goes in cycles, why does the entropy reset? How do we get a clean slate? Penrose's theory, Conformal Cyclic Cosmology, or CCC, suggests that the universe doesn't need to crunch to end. It just needs to forget how big it is. In the far, far future, all stars will burn out. Even the black holes will evaporate through Hawking radiation. Eventually, the universe will contain nothing but photons, light particles. Here is the trick. Photons have no mass. And because they have no mass, they do not experience time. They do not experience distance. To a photon, the size of the universe is irrelevant. A universe expanding forever eventually looks mathematically identical to the Big Bang. The end becomes the beginning. The aeon rolls over. But Penrose says this transition isn't perfect. Information leaks through. In the previous universe, the previous aeon, monstrous supermassive black holes would have collided. These collisions send out gravitational waves, ripples in the fabric of space-time that are so powerful they shake the very foundations of reality. When the new Big Bang happens, these ripples are still there. They get imprinted onto the new universe like a fossil in rock. Penrose calls them Hawking points. When he analyzed the map of the cosmic microwave background, he found them. Rings, concentric circles of slightly higher temperatures. Circles that shouldn't be there. Critics argue these could be statistical noise. But if Penrose is right, those rings are the gravitational echoes of black hole collisions that happened before time began. We are staring at the tombstones of a dead reality. We are walking in the graveyard of the universe that came before us. The cyclic models suggest a line of universes, one after another. But there is another possibility. A possibility where the beginning is happening all the time. This is the theory of eternal inflation. It suggests that nothingness is not empty. It is filled with a volatile energy field called the inflaton field. This field is like a pot of boiling water. It wants to expand violently. And it does. Most of the multiverse is expanding faster than light, forever. But in random spots, the energy decays. It stops expanding and dumps its energy into creating matter. That stop is a Big Bang. A pocket universe is formed, a quiet bubble in a violent ocean. Our entire cosmos, everything we see, every galaxy, every void, is just the interior of one tiny bubble. Outside our bubble, the ocean is still expanding, and other bubbles are forming right now. This idea leads to a terrifying conclusion. If inflation is eternal, then there are an infinite number of bubble universes. In an infinite multiverse, everything that can happen will happen. Infinite times. There is a bubble out there where the Earth never formed. There is a bubble where the dinosaurs developed a space program. And somewhere, mathematically, there must be a bubble identical to this one, where you made a different choice this morning. The Big Bang wasn't the beginning of everything. It was just the moment our local neighborhood cooled down enough to let us exist. We are not the center of the stage. We are just a microscopic glint of foam in an endless sea. Finally, we must consider the mirror. Physics is obsessed with symmetry. For every positive charge, there is a negative. For every action, a reaction. But the Big Bang breaks this symmetry. It flows only one way, forward. Why? Some physicists at the Perimeter Institute have proposed a solution that restores the balance. What if the Big Bang didn't just create our universe? What if it created two? One universe moves forward in time, that is us. The other moves backward in time. This anti-universe would be dominated by antimatter, but to the people living in it, time would feel normal. They would see us as the ones moving backward. They would see us as the antimatter. This theory, CPT symmetry, is elegant because it solves the mystery of dark matter. It explains why the universe exists at all. It suggests that we are only half of the picture. Somewhere, on the other side of the Big Bang, lies our reflection, drifting away from us into the deep past. We can never meet. We can never communicate. But we are forever linked by the moment of our mutual creation. A bounce, a bubble, a reflection. None of these theories are fully proven. We are still monkeys on a small rock, trying to reverse engineer a machine that was built 13.8 billion years before we were born. But notice what all these theories have in common. None of them accept nothing as an answer. None of them accept that the universe simply turned on from a void. Nature operates in cycles. Seasons change. Cells regenerate. Stars die to create the elements that make our blood. Why should the universe itself be any different? The idea that the Big Bang wasn't the beginning removes the loneliness of a singular creation. It tells us that we are part of a lineage. We are the inheritors of energy, matter, and physics that have been played out countless times before. Perhaps the universe is trying to perfect itself. Perhaps each cycle is an experiment. Or perhaps it is simply breathing, and we are just a part of one single exhale. So tonight, as you drift off to sleep, don't worry about the end, and don't worry about the beginning. In a circle, they are the same thing. We are just here for the journey. If you enjoyed this voyage into the unknown, and if you want to be here for the next cycle of discovery, please subscribe. Share this video with someone who needs to look at the stars tonight. I'll see you in the next one. Sleep well.